Hello, so today our lesson is about area of trapezoids, rhombuses, and kites. So the first thing I want to talk about is a little bit about dimensions and the units we use when we use dimensions. So I'm going to do a little side note over here. So you can put this on the back of your notes or wherever you have a spot in the margin, doesn't matter. So when we talk about things in one dimension, that's going to be things that are we're measuring length. Okay, so our things just go in, it's like a line. Okay, you can go back and forth, but you're only allowed to go that one direction. Okay, so that's one dimension, and we have no exponent on our units. So our units might be inches or feet or centimeters, okay, meters, things like that. Okay, if we have two dimensions, when we're using two dimensions, here we're talking about area, and we go from left to right, so that's one dimension, and we also go up and down. Okay, so this is things that when we fill in a whole area like this, first one we could measure a segment like that, okay? And so our dimensions, our units for area are going to be inches squared, feet squared, centimeters squared, meters squared. Okay, so there's two dimensions, so we have an exponent of 2. And then our last one is 3 dimensions, and this is volume. So when we have 3 dimensions, we have the left and right, the up and down, and now we get this other one that makes it so that it's 3-dimensional. So here we might have like a cube. Okay, and we want to figure out how much space does that cube occupy. And since we're traveling in 3 dimensions, we're not traveling, but we're measuring 3 dimensions, our units here are going to be inches cubed, feet cubed, centimeters cubed, meters cubed. Okay, so that kind of can help you. If you remember how many lines does it take, how many lengths are you measuring, that will help you remember the units that are going to be involved. Okay, so back to our notes for today. So today we're talking about area of trapezoids, rhombuses, and kites. Once again, our notes are going to be pretty quick. Most of them are already typed out for you, and then we have 3 examples. So let's kind of review rhombus. So remember, if we have a rhombus, trapezoid. Let's review trapezoid. So if we have a trapezoid has 2 parallel sides, and the other 2 sides are not parallel. And so when we talk about the bases of a trapezoid, are the 2 parallel sides. Okay, so there's 2 of them. And the height of the trapezoid is the perpendicular distance between the bases. Perpendicular distance between the bases. Okay, so our first theorem is the area of a trapezoid. The area of a trapezoid is 1/2 the product of the height and the sum of the lengths of the bases. So essentially what's happening here is we are averaging the bases, right? So 1/2 times base 1 plus base 2 is the average of the bases. So what we're kind of doing here is, if we have a trapezoid, we're saying, hey, if I average this here and I take this area of this rectangle, then I have that. So I have base times height, but I have to take the average of the bases first. So that's kind of the idea there. But the formula, that's all you need right here. Area equals 1/2 of the height plus the sum of the bases, or times the sum of the bases. An example. All right. So the free throw, it's called a lane, not line, in international basketball court is shaped like a trapezoid. So find the area of the free throw lane. All right. So if we look at this trapezoid here, we first have to identify our bases. So our parallel sides are this 3.6 and this 6 meters. So area, I'm just going to write down my formula again, is 1/2 times the height times the sum of the bases. Okay, so 1/2, and my height is the perpendicular distance, so that's going to be 5.8 meters. And then my base 1 is 3.6, and base 2 is 6. So then I'm going to get, when I plug all that into my calculator, I am going to get 27.84. And since we're measuring area, that is going to be meters squared. Our next example, or our next theorem, is the area of a rhombus. And the area of a rhombus is 1/2 the product of the lengths of its diagonals. All right? So what we're doing here is we're saying, hey, if I look at this, I can create a rectangle here by moving that one over here, and I can create another rectangle here by moving that one over here. So essentially, I have a rectangle that is half of the rectangle that if I did all of it, like kind of like this, right? So this is the half here. That would be my total rhombus, okay? If that makes any sense at all. I have no idea if that made sense to you, but it's just kind of like reshaping the pieces and saying, hey, if I look at both those diagonals and create a rectangle around all of it, the rhombus fills up half of that rectangle. Okay, so let's talk about the area of a kite. Area of a kite is very similar. Area of a kite is 1/2 the product of the lengths of its diagonals. Okay, so the area of a rhombus and the area of a kite are the same because we just have 4 triangles and they fill up that rectangle differently, but they both fill up they're both half of the area of a rectangle that goes around the vertices. Okay, let's do some examples. Example B. The rhombus PQRS represents one of the inlays on a regular guitar in the photo. So if you look real close on this photo, we're talking about these little tiny rhombuses behind the strings up here on the neck of the guitar. Okay, so they give us the picture of it. And so we have that 9 millimeters goes from Q to N, and that 12 millimeters goes from P to N. So my total diagonals, so diagonal 1 is going to be 2 times 9, so that's 18 millimeters. And diagonal 2 is going to be 2 times 12, so that's 24 millimeters. So my total area is going to be 1/2 times diagonal 1 times diagonal 2. And I don't know why I dotted my 1. Let me erase that because that's bothering me. So my total area is 1/2 of 18 times 24, which is going to be 216. And my units are millimeters, so millimeters squared. Okay, next example. Says one diagonal of a kite is twice as long as the other diagonal. The area of the kite is 72.25 inches squared. What are the lengths of the diagonals? Okay, so let's draw ourselves a kite here. So a kite, remember, has adjacent sides that are congruent and no parallel sides. Okay, so we're talking about diagonals here. So if I have this diagonal, sorry, my kite's a little lopsided, that's okay. So one diagonal is twice as long as the other one. Okay, so let's call this vertical diagonal, diagonal 1. And so, oops, let me draw it this way. Let's see here. Let's draw it this way. So diagonal 1 is my vertical one. So diagonal 1, and diagonal 2 is my horizontal diagonal. Okay. Let's call diagonal 1 X. And then one diagonal is twice as long as the other diagonal. So that means diagonal 2 will be 2x. Okay. So the area of a kite, remember, is 1/2 diagonal 1 times diagonal 2. And if I plug in all of the pieces, so area, we can plug in the 72.25. So I'm going to pop that in. 72.25 is on this side, equals 1/2. And diagonal 1, we're calling x. and diagonal 2 is 2x. So then I get 72.25 equals 1/2, and then x times 2x is 2x squared. And then I'm just doing this step by step. You could skip that step I just did, and then 1/2 times 2 is 1, so I just get x squared equals 72.25. Take the square root of both sides. And when I take the square root of both sides, I am going to get x equals 8.5. And then my other diagonal is twice that much, so I'm going to get, so that's diagonal 1 equals 8.5. And what's my units here? My units are inches, because that's a length. And then diagonal 2 is twice that. So diagonal 2 is going to be 17 inches. Okay, so my diagonals are 8.5 inches and 17 inches. All right, that is all the notes for today. So go ahead and do the homework problems. Remember, notes are due at the end of the day and homework problems are due next class. Thank you.